Hello everyone. In previous session, all of you already learned about algorithm for linear and binary search. Now, we will discuss about program for linear search and binary search using C. Program for linear search. In linear search, we search one by one element. Here, in this example, size of n is 5 and value of key is 4. So here we first compare our key to the first indexed value, that is a of 0 is equal to key. A of 0 is 5, so 5 is equal to 4. This condition is false. Then I is incremented by 1 and we shift to the next index. So here 6 is equal to 4. This condition is also false. Then we move to the next index, that is 4. 4 is equal to 4. This condition is true. Then here we stop our program and print element is found. So see here in this program, initialize a 20 means A is array name, 20 is size, I is index, key search element and N is size of array. We first create an array. Printf enter the number of elements in array. Scanf %d address of n. Here n is size of array. Example, we enter n is equal to 5. Next is printf enter %d numbers comma n. So here n is 5, so output is enter 5 numbers. So here for I is equal to 0, I less than n, I plus plus, scanf %d address of a of I. So here value of I is 0 means we first insert value in 0th index. So we insert 5 in here 0th index. Now I is incremented by 1. So here a of 1. So we enter value 6 in this index. Similarly, we enter all this value one by one. Next is printf. Enter the number to search. Scanf %d address of key. So here we enter value of key is 4. Now for loop is I is equal to 0, I less than n, I plus plus. Means I started from 0 and I less than n means n is 5. So 0 to 4. So next condition is if a of I is equal to key. So here a of I, first I is 0. So a of 0. So a of 0 means 5. So 5 is equal to key is 4. So 5 is equal to 4. This condition is false. Then our I is incremented by 1. That is now I is 1. So A of 1 is equal to key. So A of 1 is 6. So 6 is equal to key, that is 4. 6 is equal to 4. This condition is also false. Then I is incremented by 1. Means now 1 plus 1 is 2. Our I is 2. So A of 2 means 4. 4 is equal to 4. This condition is true. Then we check this condition if I is less than n. Here I is 2 is less than n. N is 5. This condition is true. Then we print here key. So in %d our key is 4. So 4 is present at location here %d, that is I plus 1. So here is I is 2. So 2 plus 1 is 3. So here output is 4 is present at location 3. Why we use here 3 I plus 1? Because 1, 2, 3 means user location is 3 but array index is 2. If element is not present whole in this array, then print element is not found. Output of the linear search program. See here, enter the number of element in array. We enter 5, means size of array is 5. Then enter 5 numbers. So we enter 5, 6, 4, 2 and 9. So we enter these 5 elements. Next is enter the number to search. So enter 4. So output is 4 is present at location 3. Program for binary search. In this binary search, we first find out middle element, then we divide array in two parts. If middle element is equal to the key, then here we stop our algorithm and print element is found. Otherwise, we go to the next case, that is we compare our middle element is less than or greater than key. If middle element is less than key, then we search element in the right side. Otherwise, we search element in the left side. So see here in this program, first int I, initialize I is used for index. Then bg is used for indicating first index. End is used for indicate last index. Middle is used for indicating middle index. N is used for size of array. K is search element. Declaration of array, that is array name, and size is 100. Now we create an array. So here we use printf, enter number of elements, scanf, mod d, address of n. So here we enter value of n is equal to 7, means size of array is 7. Now we insert element in this array. We use printf, enter mod d integers, comma n. So here our n is 7. So output is enter 7 integers. Using for loop, I is equal to 0, I less than n, I plus plus. So here I started from 0, I less than 7. So I move to 0 to 6 location. Next is scanf mod d, address of array of I. Here first I is 0. So here we enter first element to the 0th index. Next, I is incremented by 1. So we enter element in first index. Similarly, we enter all this element. Next is printf, enter the value to find. Scanf mod d, address of key. Here our key value we enter is 11. Next is beginning is equal to 0, means beginning is point to the 0th index. End is equal to n minus 1. Here n is 7. 7 minus 1 is 6. So we point to the last index. Next, middle is equal to beginning plus end divided by 2. Here beginning is 0 and end is 6. So 0 plus 6 divided by 2 is 3. So we got here our middle index, that is 3, and middle element is 9. So next is while loop, that is beginning less than equal to end. So here beginning is 0 and end is 6. So 0 is less than equal to 6. This condition is true. Then we go to the if condition. In if, array of middle less than key. Here array of middle is 9. So 9, our key is 11. So 9 is less than 11. This condition is true. Then we shifted this beginning to the right side. So here for shifting this beginning to the right side, use statement beginning is equal to middle plus 1. So here our middle is 3. So 3 plus 1 is 4. So we shifted beginning to this index. Next, this is our beginning and this is end. Now repeat this procedure. Middle is equal to beginning plus end divided by 2. So here beginning is 4, end is 6. So 4 plus 6 divided by 2. 4 plus 6 is 10 divided by 2 is 5. Then our middle element is 43, means we indicate in fifth location. So this is our middle index. Okay, now our beginning is 4, middle is 5 and end is 6. So now we check this procedure from while loop. So while beginning is 4 less than equal to 6, this condition is true. Then we enter in this if condition. If array of middle is less than key. Here array of middle is 43. So 43 is less than 11. This condition is false. Then we go to the next statement, that is else if condition. Here array of middle is equal to key. Array of middle is 43 is equal to key. This condition is also false. Then we go to the else part. In else part, end is equal to middle minus 1. So here middle is 5. So 5 minus 1 is 4. Now our end is pointed to the fourth index. Okay, so here our beginning is also fourth index and end is also point to the fourth index. Now repeat this procedure to find out middle element. So middle is equal to beginning plus end divided by 2. So here beginning is 4 and end is also 4. So 4 plus 4 divided by 2 is 4. So now we got our middle element, that is 4. So here our beginning is 4, middle element is also 4 and end is also 4 position. So we repeat this procedure while beginning is less than equal to end. So here beginning is 4, less than equal to end is 4. So 4 less than equal to 4. This condition is true. Now we check if array of middle less than key. Here array of middle is 11 and key is also 11. So 11 less than 11, this condition is false. Then we jump to the next condition, that is else if array of middle is equal to key. Here array of middle is 11. So 11 is equal to 11. This condition is true. Then print mod D is found at location mod D. Means first mod D is key. That is key is 11. So 11 is found at location middle plus 1. So here middle is 4. So 4 plus 1 is 5. So our output is 11 is found at location 5. Why we write here middle plus 1? Because here fourth index is array's index, but 1, 2, 3, 4, 5, this is fifth index is user index. So we write here middle plus 1, that is 4 plus 1 is 5, means output is 11 is found at location 5. Now here program is stopped. In second case, means if element is not present in this whole array, means key is not present in this array, then we jump to this if condition, that is beginning is greater than end, then print element is not found, means not found mod D is not present in the list. Means 11 is not present in the list. If our key is not present in this list. Output of the binary search. First we enter number of elements. Means we enter 7. Means we created array of 7 elements. So we enter 7 integer, that is -4, 5, 8, 9, 11, 43, 485. Okay, here we enter number in sorted ascending order. Okay. Next is enter value to find. Our key is 11. So we found 11 found at location 5. 1, 2, 3, 4, 5. I hope all of you understand linear search and binary search program. All of you keep practicing these programs. Thank you.